little bit behind schedule by 10 minutes or so. But it's okay. So I'm very pleased to introduce Mr. Shrirang Deshpande, country head for the data center business at Emerson. And this afternoon he is going to be talking about smart solutions and an integrated infrastructure. Please welcome Mr. Shrirang Deshpande.
Good afternoon to all of you. Some different topic today on infrastructure. Okay, hello UI. I'm speaking about the passive infrastructure part of it. We have been speaking a lot about IT, mobility, and all that. So this is different change. We will be talking about smart solution. Smart solution in the definition of Emerson, we call it the data centers. Server rooms, data center, network process, different names. But in arena of Emerson, we call it smart solution. What is so smart about it that we will understand? And why it is smart is because they are integrated intelligence to deal with any challenges of IT which you might be facing for both communication as well as IT. So let's move on how it is all about. You see, any data center will have typically 3 layers, which you are very familiar with. We'll be concentrating our discussion on the physical layer, which is the bottom layer, which calls about space, power, cooling, and many of other stuffs from safety, security, monitoring standpoint. The second layer is a middle layer, which is IT infrastructure, where you have computing devices, storages, network components, and then you have application layer, where you have all enterprise applications, which you are now looking into. So our discussion is going to be today primarily on the physical layer of systems. What are the challenges of physical layer? What are the issues which we need? How do we overcome that? And the importance of this physical layer is something which you have to build for a longer period of time. But at the same time, the middle layer, which is IT infrastructure layer, may go for refresh every 2, 3, 4 years depending upon the cycle of technology, depending upon the requirement of your businesses, so and so forth. So when you're changing this IT infrastructure layer, the middle layer, you cannot change physical infrastructure every time. So you have to make the infrastructure, passive infrastructure we call it. I talk about either physical infrastructure, passive infrastructure or a data center, which is same. You have to make that infrastructure which is supporting a complete life cycle of minimum 2 to 3 years to refresh, which means it could be anywhere between 6, 7 to 10 years. It's all dependent upon how you're growing. It all depends upon how you're adapting to various technology changes. Right? Now, when you talk about physical layer, because that's a layer which is running your technology. That's a layer which is running your application or businesses. And we have to ensure that that particular physical layer is supporting your technology for highest degree of uptime. Uptime, either you call it as uptime, you call it as availability. And that's where the whole approach of a design comes in. How do you develop high 9 based systems? What do you mean by high 9? We commonly talk, I need at least 99%. But in the arena of technology infrastructure, what is 99%? Let's look at it. We have to identify how critical is the uptime for my business, or how critical is the uptime for a particular application. It could be business, it could be customer-oriented application, it could be engineering application. Depending upon that, the application uptime or infrastructure uptime may differ. We talk 99 very commonly. Do you afford to have your infrastructure available for 99%? The answer is no. Because your business will never allow you to have a downtime of 90 hours. Am I right? Which means you have to develop a system or an infrastructure or overall physical layer to add more lines beyond 99. So I don't think any business today will allow you to take 90 hours of shutdown in whole of year also. You have to make some provisions, you have to make some redundancy, you have to make some failure situations. Still, nobody will allow. So, to increase high 9, we have to invest every 9 getting added, it's an additional investment. because you are making your system, your infrastructure more robust, more resilient, and more performance oriented with the highest level of uptime. Okay? So today, we as a people, we as an organizational key makers, key decision makers, we have to decide what is the level at which I should be able to reach, and based on which we should plan our investments, we should plan our capital budgets, and so on and so forth. Now, you might have heard very commonly in data center arena that tier class, tier 1, tier 2, tier 3, tier 4. And tier 1 to tier 4, it's advocated by Uptime Institute, right? Being adopted by TI 942. TI 942 is a standard, Telecommunication Infrastructures Association standard, which guides us for how to build data centers, how to build physical infrastructure, how to build your entire passive infrastructure for that matter. Now, when you talk about tier 1 to 4, obviously 4 is highest available or fault tolerant, and tier 1 is just a single system. So in between there are tier 2 and tier 3. As you go from tier 1 to tier 4, you are increasing your lines, which means you are increasing your redundancy. You are avoiding single point of failures. You are trying to make systems more and more robust. So any calamity, any situation, any problems which is impacted on the facilities or infrastructure will not affect your data centers. And that's how you plan for either tier 2, tier 3, tier 4, depending upon your business requirement, depending upon what you want to achieve. Now, before we understand how you classify those tiers, let's look at what are the important components of data centers. Just a building block actually. Obviously, you will have the green boxes are nothing but very familiar equipment for you, network equipment, storage equipment, or rack, in which you are physically keeping all these devices, surrounded by a lot of other stuff like distribution, which you have a network room, hub room, switching room. You have a staging and storage where all the material before entering into a data center is being kept, is being prepared for to keep it inside, installed, or applications are being loaded, and only then you are allowed to, or you only then, as a practice, you should be taking that inside. A tape vault, though it is shown here, it should not be here, because tape vault is nothing but a backup data. You can't keep it in the same place, you have to keep some different place. But it is being a part of data center being shown here. Physically, it is somewhat different. You have to plan your data center or systems for any calamities, like fire safety situations, monitoring, surveillance, security. There are a lot of threats, internal threats, external threats, building issues, because most of the buildings are tenant, many tenants are available in the same building, so it's very difficult to manage. So fire safety is a very important aspect. Of course, UPS systems and generator. UPS system will ensure you that you are getting a reliable power as well as backup system. And generator ensures that in any part of India today, we have at least 20-25% of deficit in electricity. So at no point in time you are assured that you have a constant power available. So you have to always make a backup power systems available in your campus or in your building or in nearby infrastructure. So generator and UPS systems are always there for you. And all these IT devices which are being put in the racks generate enormous amount of heat, and that heat is somewhat different than our body heat. So it's a latent heat, what is emitted by body, and the heat which is generated by the systems or devices is sensible heat. Okay, and sensible heat calls for a different level of HVAC. So when you are in comfort air conditioner, probably the sensible ratio could be anywhere around 65 to 70%. But the same comfort AC, if you have to use for a data center, it may not work, because you have to deal with 95 to 96% of sensibility. So HVAC systems, these are the basic building blocks of a data center. Now look at how the tier classification is managed. As you see clearly, tier 1, tier 2, tier 3, tier 4. Here N is nothing but a need. What is your basic need? What's your calculated need? It could be ratings of the systems, it could be ratings of the UPS systems, backup systems, or air conditioning systems. And based on the requirement of reliability, you can travel from tier 1 to tier 4. Now from tier 1 to tier 2, you have only few components which goes as redundant. In tier 3, you have almost all the components are redundant, but in n plus 1 category, mean plus 1 or mean plus 2. Okay, and in tier 4, you have 2n, which means you are investing for x plus x to x as well. And here, in tier 3 and tier 4, you are completely avoiding a single point of failure. For example, I have redundant UPS systems behind, and they are parallel and delivering me a common supply. And whenever one is going to fail, second is supposed to take care, right? But the cable which is laying between UPS to my rack is in. So what is the use of having redundancy at system level? It may not suffice. A system level redundancy is definitely essential, and beyond that, any problem? Okay. So system level dependency is not only required, but you require path level, distribution level redundancy also. And that's how these tier classifications are addressed. Now you can see the blue components are primary components, which is your read, and red components are redundant components. So when do we decide which tier class you require? Again, it's all dependent upon what's the business requirement of yours, how much downtime your business can afford. And then if you go back to my high 9 slide, you can reach to 99.98 to 999.995 depending upon how you are building those redundancy. And you're going from tier 2, tier 3 to tier 4, you are increasing the nines. Right? Okay. When you are building data centers, what is an approach you have? I don't know whether you cover all this approach. Like what's the first and foremost is define the origination of that requirement. It's the requirement by the business. What is business requirement? Then what are the issues with respect to risk? Where is the location of that data center? Is it risky? Are there any issues with respect to natural calamities? Are there any challenges with respect to any other threat outside data, outside the building? How you are going to mitigate that plan? You should have a strategy in place. How you are going to grow? You have to extrapolate that while you are defining the needs based on your previous experience, based on your industry experience, so on and so forth. And all this capturing together, all the information being captured together and then develop. Right? So all these elements are very important. Not just I have so many servers, I have so many network devices, and I require some no. You can't do it. Okay. Now if you look at typical data center chain, it starts from the grid and it ends at chip. Grid means nothing but power, which is entering into a substation, and from substation it is entering into your devices or a data center. And in between you have many devices, like you have backup systems, like generator level backup or substation level backup, and a changeover system. Then you have internally in data center you have UPS systems or DC power systems. Then you have medium devices. Then you have DC power systems, enclosure systems, HVAC systems. So this is, you have to look at entire grid to chip as a complete value chain when you are defining. Beyond, one is the data to build approach. And second is when you are defining this grid to chip, you have to look at every aspect and every stage here. And that's how the value chain is there. Emerson has been enormously contributing in this particular value chain. And that's where we say that we are enabling business critical continuity for various customers. Now, if you look at what are the components of data centers, and this is a typical model of data center. You have UPS systems being kept aside. You have battery systems. You have some switchgear, panels, distribution, DBs, and all that. You have surge protection devices. Surge protection devices have normally not been used, but it is very important to create electrical hygiene. Electrical hygiene is nothing but you are making your system free from all electrical pollution. As India, power is not only issue, it's reliability of power, quality of power is again issue. You have to deal with it. And that's how self-sufficient devices become more important. Then you have, depending upon the density of cooling or depending upon density of racks which you are going to populate in the cabinet or how many devices you are going to populate, based on which you can decide a type of cooling system. It can be small, medium, large, or extra. Like typical high performance computing calls for high degree of data, high density of data center cooling systems. So based on business requirement, you can define a cooling approach. Within rack also, certain systems are available rack level cooling systems which are being mounted on the rack. And in the rack you have managed PDUs who can help you to monitor the granularized power management, who can help you to schedule of shutdowns of various devices when they are not in use. Can help you a lot of KVM management systems is all there inside the racks. So this is indirectly a footprint of immersion also. What is not captured here is fire safety, which is fire detection, early detection, then smoke detection, suppression, which is typically gas-based systems, FM200, NOVAC kind of thing, and civil interior work, which is nothing but a false flooring, false ceiling, to make it more agile from a logistical perspective, keeping in the practice of cold and hot eye. And then the new trend, which I just wanted to touch upon, is the container data center. This is something which is very fast and easily deployable. You don't require any building. You can have just barren land, just already available there, and you can simply deploy. If you are able to predict your growth, generally data centers are built. A planning may require 1 year or 1.5 years, depending upon the size of a data center. But acquiring the space, building the building, and getting into data center, it can take anywhere between 1 year to 2 years. And if business cannot stop, if business does not allow that 1.5 to 2 years, container can be obvious options. Where you can straight away, these are all pre-configured containers. You can define the need accordingly, it is configured in the factory, and it comes and gets required at the site. Just what you require is a barren rack with a protected caging or security and a power outlet. Typically your greenfield projects, dam projects, it can be mounted on terrace also, it can be mounted on parking lots also. There are quite a few demands which we see in India. Okay. Typically any business is being forced by two forces, one the internal force and external force. External forces are nothing but a business climate change. A climate change of a business is everyday scenario now, which is always impacting on a business, which is always impacting on technology infrastructure, and hence on a facility. Because today all business promises are delivered by a technology. And so today you can't say that this is semi-critical, this is hyper-critical, this is mid-critical, this is non-critical. No, everything is critical. Even if a wall-mounted rack, small rack of 19, even if it is problem, it is become critical. So today the level of SLA which is demanded by a small wall mount is same as that of data center. Because you have connected some important devices here, you have connected some of your important employees of this organization, and they can't afford to be disconnected on the network. So today, everything that you do, it calls for enterprise class of or high critical degree of service levels. We talked about external forces. Internal forces are nothing but you have to revisit technology as an internal force. You have to change your applications. So there is a continuous amount of some projects which keeps on going on in IT. It could be consolidation, it could be virtualization, it could be addition of some devices, it could be deletion of some devices. Some of the other issues are happening. And these issues are translating or can be bigger when your infrastructure is not supportive for you, and which has a tremendous amount of impact on our facilities. So when you are planning for your facility, you have to consider that every 2 or 3 years you are going to revisit your technology infrastructure, and whether your physical infrastructure is going to support you that way or not. That is very critical. Now, to support all these challenges, data centers are being used. And data centers are being designed, and depending upon the criticality index, depending upon the requirement of the business, you can define. Depending upon the size of your organization also you can define. There are many options available. A data center in a cabinet, a data center in a few racks, data center in a complete aisle, data center which is purely customized, that you have just a space and you want to plan your data center. And last is a container data center which I have already spoken. I am going to concentrate more on smart cabinet and smart road because that is more intelligent than intelligent and integrated data center. What do you mean by that? Whatever we have spoken so far, like data center require power, cooling, redundancy, fire, safety, monitoring, everything is integrated in the form of cabinet, right? And that particular SLA or that particular availability of the system is of an enterprise class. By doing this, you are not compromising it. So cabinet is typically a network closed-set cabinet which is used, a single rack, a double rack application, maybe some bank or insurance company or maybe some warehousing system, you have single rack system, have local server, couple of devices in the network, but you require availability there. So you can't build data center at your C&F agent, right? The best way is that you build a cabinet, and that cabinet should have a highest degree of SLA commitment by way of redundancies, by way of all the failures or calamity what that cabinet can see. And the application could be your network process, your warehousing, your storage systems, your branches of banks, branches of corporate organizations, anything. I mean, you can decide what, instead of building an entire server room in particular location, maybe a plant, you may have a central data center X location of A class AG or B class AG. And you have a plant in somewhere else, you still require server room there from local database perspective or some messaging perspective or from some enterprise planning perspective. That can be utilized. Same is the case with row. It's a multiple of racks. It could be 2, 3, 4, 5, 6. And it can grow. See, the most important is that why these combinations are made. When you build a data center, you cannot build it for today, just tomorrow. You have to predict the growth for next 5 years, 6 years, because management is not going to give you budget every day, every year. You have to predict the growth and you have to invest. So which means you might want 25% of the capacity today, but you invest for 100%. Because knowing that an additional 70% is going to 75% is going to come to you after 2 years, 3 years, 4 years. Which clearly means that you are investing more than what you require. And when you invest anything more than what you require, you end up paying cost of OPEX also, unnecessarily. So the approach should be such that how your infrastructure can grow along with you. You should not have a situation that, okay, I have made a data center of 100 racks, but I am really using some one corner of 2 racks, 5 racks, 10 racks. No, it is not right. It's not a right approach. So you should follow an approach which grow along with you, or it can go as on demand. And that's the reason all this combination of cabinet-based, row-based, hive-based, or design-based. So you have to be sure today what you require. You have to be sure today how you are going to grow. Or it is very difficult to predict at times. Nobody, I don't know how many of you can tell me that, okay, 3 years down the line, my infrastructure is going to be like this. Very difficult to answer. Because climate changes are going to be there, business changes are going to be there, technology changes are going to be there. Maybe some merger or acquisition will again lead to some challenges. But that's where our approach is that you grow your infrastructure as actual growth of your organization. And that's the reason you have rack-based systems, you have row-based systems, you have room-based systems, and you have site-based systems. And that's how you can adapt. This is truly adaptable approach. That your infrastructure is getting adapted to the requirement of the growth. Right? I'll give you a classic example. I don't know how many of you are there from insurance company. When they started a business, they have predicted some infrastructure, maybe 50 lakhs, 50 lakhs. But I know I can't name them. There are at least 4 companies. Within 3 years, they have to rebuild one more data center. Because growth in the business was such a high that existing infrastructure was not able to support it. So all the challenges you have to deal with and then come out with problem. What is smart solution? I discussed with you about various configurations. Let me take you through one video.
The rapid innovation of technology has impacted the way businesses approach data center infrastructure design and deployment. Common data center problems, such as overheating, high energy consumption, low cooling efficiency, separate management platforms, low reliability, and longer project turnaround, can be resolved with an integrated infrastructure solution. Backed by its long-standing tradition of data center expertise, Emerson Network Power presents the new SmartRow solution for smart and mid-sized data centers. SmartRow innovates the traditional design approach for small and mid-sized data centers, integrating power, cooling, and management systems into one compact, manageable suite. SmartRow is suitable for limited data center space, packing performance, efficiency, and availability in a small footprint. The centralized monitoring system connects all system components. SmartRow uses just one interface to manage and monitor all its critical components for optimal planning and management. With a single display, your data center operation is under your control. SmartRow is available in two configurations, closed cold aisle and closed hot aisle. SmartRow with closed hot aisle enhances the AC compressor efficiency and can be placed anywhere, even in environments where people are working. It is the most ideal solution for limited room space. Meanwhile, SmartRow with closed cold aisle reduces the loss of cold air and is ideal for rooms bigger than 20 square meters. The closed cold aisle configuration of SmartRow enhances cooling efficiency and guarantees optimal PUE. SmartRow comes with an emergency fan system. If the cooling unit goes down, the emergency fan will be triggered automatically. Hot air will then be released out of the SmartRow. SmartRow's modular design means expansion can be deployed at one time or in phases. It is flexible to meet various application scenarios, common in small and mid-sized data center expansions. It can be configured from 3 racks to as many as 6. SmartRow offers standardized data center deployment and shorter time for implementation. SmartRow is designed for fast and easy deployment and can be installed and ready for use in just a few weeks. SmartRow offers you the complete data center package with turnkey capability only from Emerson Network Power. SmartRow is optimized to be user-friendly from deployment phase to actual operation. Emerson Network Power's SmartRow solution, the road to be smart. The rapid innovation of technology has impacted the way businesses approach it.
Okay. And we have tried to show you what is the difference between conventional systems and integrated systems. Many of you may be familiar with conventional system, which creates a lot of wires, bunch of doors are open, some data center IC fans are enforcing here, some cooling into the rack. That's all happened. It's a lack of planning, lack of proper design approach is what we see here when we visit many of the data center. And then this leads to the challenges when you want to grow, the data center doesn't support you. If you want to put some base servers, that doesn't support you. If you want to remove something, some challenge, some of the other challenges. So we thought to give you some idea about what is the conventional vis-a-vis. Now, what are the beyond conventional benefits? Beyond conventional is nothing but you are making some web work, making some brick and mortar, building that room, doing a lot of internal work and all that. Huge amount of dependency outside vendors, a lot of stakeholders. To completely avoid that, we thought, why not we deal with that particular challenge of time. 1. 2, on the real estate. Well, you could have seen in video that it is very compact. It's so compact that it can save you at least 25-30% of the space, which normally would have spent through a conventional data. And that same space can be utilized for your next floor. So when we thought of intelligent integrated data center developing, development. We had three, four things in our mind. One is that we should protect capital expenditure for the customer. So I told you, it can go as it go. Two, it should save the space because real estate is a huge cost. And most of the server rooms or critical server rooms or data centers are there A, B, and very limitedly C class cities where the real estate is important aspect. Third, another important aspect is operating cost. We have tried developing the system considering the most energy efficient devices. And that's how it saves you a lot of operating cost saving also. And the last thing what we are going to do here is we are going to provide you remote management. See, many of the time, this all data center required 24/7 management and monitoring, which means you require to deploy some resources 24/7. And those resources become that time so critical that if that person is not available, data increase, I don't know what is going to happen. So dependency goes so high that and develop additional resources, cost is becoming very unnecessary. So what we thought, why not we give a remote management where we will continuously monitor those on the smart cabinet, smart door, or whatever devices you have for the performance, health and safety. And that's where we have decided to add that. Now when we decided to approach this particular infrastructure, we have three important challenges which we discussed. We wanted to give you a high degree of availability, which is to ensure that you have high nights and high uptime. But when you increase the number of redundancy, you are going to lose on the efficiency. A system which is going to be available, same system is being supported by many, it is going to be less reliable and less efficient. So that balance we have achieved. Secondly, you may see that changes, the IDs are evolving continuously, and devices are new devices are going to come, which are of different makes, different capacities. So you should give a flexibility in the capacity. For example, you have decided to change from a tower type to a rack optimized to blade server. Does the data center support? Yes, this works. And high density. When you are essentially going for a blade servers or multiples of blades or large amount of storages, it requires high degree of power or high degree of cooling, which is dead here. So this is a framework under which we have developed the system, and that's how all the challenges which we have circled around, we feel that can be addressed. But if there are many other challenges or any other challenges, we would like to deal with them. Efficiency of a data center is just not buying an efficient product. It has to come via life cycle. So not buying an efficient product, but also handling the design deployment more efficiently, handling entire operations more efficiently makes much more important. Because today you may buy a 99% efficient system, but it is not being managed properly, that 99% may not go. So efficiency of any infrastructure comes out of a life cycle, not just buying a one-time equipment selection. Okay. These solutions give you more efficient, economical, it is interoperable. These solutions, if you see, if you want to change your data center, almost 99% of the equipment you can just remove it and put it somewhere else. But in normal data center it is not possible. You may able to take some of the boxes, but here it is completely dismantleable system and you can put it in the new locations very easily. It complies with tier standards, tier 3 and tier 4 depending upon your requirement can be configured. It has complete integration of monitoring, access control, safety, security, power, cooling and entire support services which normally require for any enterprise class of a data center. Smart cabinet is a typical cabinet which I have discussed, which comes in 1 and 2 cabinet, has some different configurations here. And smart row is typically a row which again comes with a lot of redundancy in tier 3 and tier 4 class support. And this also comes with about 6 to 8 requirement of configuration. See, we have tried to make this offering more product oriented. Like you may select your configuration which will be nearby to you and then you can go for it. And as you go, you can add multiples of smart cabinet or smart door depending upon that. It has intelligent monitoring for all these aspects. You put temperature, humidity, power, cooling, everything is monitored here, which is typically when you look at any server class or any kind of an IDC or any kind of a data center, it's built under conventional scenario. Security aspects are monitored here completely. So I mean to say in one line is that anything which you either expect out of IDC or either a normal enterprise class data centers, everything is available here. intelligent systems by way of biometric access, by way of CCTV, surveillance is all available here. OPDC service, I talked about remote management service, wherein all this, we call it on-premise data center, wherein all these data centers will be installed at your places, and we will be talking to the data center, or there will be data being sent to our NOC about the status, which includes health, monitoring, performance, and utilization of your system, and by which we are able to handle your all challenges. And typically what happens is all the data center require 24/7 management. It could be either remote or it could be requiring resources at the site. And that is something which becomes very critical at times and people depend on, which we have completely avoided by going through OPDC service. In OPDC service, this is a smart solution which we have, and being monitored through our partner. Nextgen is our partner, National Alliance for this distribution as well as monitoring the systems. And we monitor performance, utilization and health so that you can define policies, controls and directives for these systems. And these are the monitoring possible through remote, which typically you may ask for. It could be power, it could be temperature, it could be humidity. So all enterprise class monitoring is available here. And there's only one or two slides here. Conventional versus smart cabinet is right here mentioning here. Like, you don't require any site preparation, you just have to make your systems or space available and instantly have to start working. You just order what is required as per the requirement and you go for it. The smart solution system is completely removable and being deployed somewhere else. Normally it doesn't happen in any conventional data center. And that's how we call it as smart. And we are trying to protect your capex expenditure for a longer period of time. So that's how we are trying to do. And it has got all the level of, you can offer you in tier 2, 3 and 4 depending upon your application requirement. And as I mentioned, energy efficiency is very key here. Any conventional data center which has integrated intelligent systems, you will at least get 30 to 35% energy saving on operating cost. So that's how the key messages from this particular slides. And thank you so much. For any question, I am available here, offline, online, no problem.
Any questions for Shrirang? Just I think there's
Yeah, I'm Ranjit Kumar. My query is that related with your remote management system. So while monitoring it from your own location or from people, do you really provide any sort of troubleshooting as well, or just monitoring?
Okay. See, the very purpose of monitoring, if you look at a typical data center, after 6 o'clock, it is left with either security guards or technicians which are available on site. Okay. But there are hardly he can react to it. He can just inform some people. He may log in the call and try to address that call. But idea is, from a troubleshooting point of view, is a very good question. When we see any challenge in that smart code at night 2 o'clock, and that is the time they want to get a message that okay, there is some problem in that system. And we have provided a monitoring system which gives us an alert from very corner of this smart cabinet or smart code, whichever the system which you have. And from there we will be able to know what are the challenges in that system, what is failed or what is not working properly. And from there itself we will enable the call logging. Probably before you come to know what is wrong with it, you would have already addressed that problem. And that's the whole idea behind remote management. So troubleshooting from a perspective, we can't remotely troubleshoot because this all systems require a physical attendant or physical presence to address it. But yes, enabling the vendor call, enabling the support call, making it faster with an SLA, with a time-bound manner is what we are offering.
There are few problems which are related to the applications or any sort of where the physical presence of the person is not required. So that kind of troubleshooting.
Okay. Let me identify this kind of problems. When we are talking remote management services, we are not really getting into IT infrastructure. We are getting only into passive infrastructure, which means of data center infrastructure. I literally does not mean that your network issues or IT issues will be addressed here or any software application related issues are addressed here. Because we come from background of physical infrastructure. problem which related to, and we don't, as a company, I don't think it will allow us to enter as a third party inside your premises in the IT network. So what we did, we kept IT management or remote management to be handled by experts of your own company or outside. We are only confining ourselves to only infrastructure what we are supplying, especially power systems, cooling systems, temperature issues, some fire safety issues is what we are going to manage. For which you otherwise have to provide a physical person there, 24/7 on 365 in the ships, or you have to make your security guard so, I would say security guard could be made as an engineer. Not possible. I hope I have addressed. Yeah, please.
A very quick question, please.
So happen in our own data center, there is a cooling units, and there is a device which is placed using the data center architecture. That device which monitors the cooling unit is placed on a sequential basis. Because that comes only in sequential, you can't make a cluster of it. Now that unit itself fails, all cooling units are working, and since that unit fails, we are not able to monitor the cooling units.
Right.
And ultimately it's so often that one cooling unit gone out of order,
Right.
created a hot spot, and finally server got removed. Do you have a solution of that sequential in parallel or something?
Okay. See, there are two ways you can address this problem, which is already addressed in the system. One is that the equipment of cooling itself should send a message, a proper message to a monitor or remote management that how is it behaving, is it a problem, is it an issue. And there is another system which we have developed independently, that we have a temperature sensor kept inside the system. Yes. Yes. The temperature monitoring and humidity also, both ways, because location-wise India has got a varied temperature pattern. So what we have done, we have not only made system being hooked up to the network command center, separately we have all temperature monitors being kept alongside of the rack or inside the rack on a critical positions. And those also get monitored. So either you will come to know from a signaling from the equipment itself, or you will come to know from a